Like to work through the last example of this section. We're talking about the basic rules of differentiation in this section. And the example is to find the slope and tangent line to the graph of a function f, which is defined as 2x plus 1 over square root x at the point 1, 3. And this point is on the graph of the function. If you check it, plug in 1 for x and 3 for fx, you'll see the equation holds. And this equation has, this problem has to be solved in a couple of steps. First, we asked to find the slope of the graph. By the slope of the graph, it means the slope of a tangent line to the graph of the function at this point, 1, 3. And then we need to find the tangent line to the graph at this point. Or in other words, we need to find the equation of the tangent line of the graph at this point. So let's just do the slope first. We know the slope to the graph, or the slope of tangent line to the graph, they're the same thing, is the derivative. Okay. We talked about that before in chapter 2. The slope is the instantaneous rate of change. In graph, it's the slope of tangent line. So to find the slope of the graph, we just need to take the derivative of the function and then find the numerical value of the slope at this point. So the question is actually asking you to find the derivative of this function. That's the first step. All right. So let's just find the derivative of the function. First, we're going to rewrite this function a little bit, in exponential form. This function is 2x plus 1 over square root of x. In order to use the rules for differentiation, we're going to rewrite the square root of x as x to the 1 to the half. And you're going to see, why we need that and how it will enable us to take the derivative of the function. Okay. So we just rewrite the square root of x as x to the half in the denominator in the second term, as the square root of x means that you take the 1/2 root of the x, and from the rule of the exponents, when you have a exponential in the denominator, it means the exponent is negative. So we can further rewrite the function as 2x plus x to the negative half, isn't it? You just change the exponent to the negative to rewrite it. Okay. From the bottom to the top, you just need to change the exponent to the negative. And then we can use the power rule to find the derivative of the function. Okay, so let's just do that. So I'm going to write f prime. You know, the prime means we're taking the derivative of the function. Okay, so make sure you know the notation. Okay, so the notation for the derivative is prime. Okay, so the derivative of the function f prime is just the derivative of each term. So we can, you know, take the derivative of 2x and the x to the negative half individually. All right. So let's just do it term by term. We can take the derivative of 2x. We can take the derivative of x to the negative half. All right. Okay. So let's see what's going on. Okay, so I don't know why it looks like this. Let me just nothing is wrong. Okay, so let me just okay. So now we can take out the constant of 2 from the first term and then multiply the derivative of x prime. Okay, so that's the first term, and then the second term is a power function x to the negative half. So that's a power function with the power negative half. According to the power rule, the derivative of a power function x to the n is n times x to the n minus 1. So in here, n is negative half. So the derivative of x negative half is just n, which is negative half, times x to the n minus 1. So x to the n minus 1 will be what? X to the negative half minus 1, because n is negative half, right? So that's the power rule. Okay, so x prime is 1, as we know. The derivative of x is just 1. All right, so you should know that. Always keep in mind. And then we can just write second term as minus 1/2, you know, plus 1/2 is just minus 1/2. Now x to the negative half minus 1. So what is the negative half minus 1? So you know, we have to use the same denominator when we add or subtract fractions. Okay, so then we can rewrite 1 as 2 over 2 in the exponent of x, and then we can, you know, combine the two fractions, or you know, add or subtract those two fractions by the numerator. So the second term, the first term is 2 again, minus half x to the what? So when you subtract negative 1 and 2, so subtract 2 from negative 1, you get negative 3. Okay, so that's negative 3. Remember, it's not the 1 or negative 1. It's negative 3. Negative 1 minus 2 is negative 3. Okay, so that's the derivative, right? Now, we can plug in x equal to 1 to find the slope of the tangent line, okay? So this is what is asked in the problem. So at the point 1, 3, x equals 1, okay. So x equals 1. So when you plug in 1 in the derivative, so we got f prime at 1. So that's equals what? 2 minus half times 1 to the negative 3/2. One thing you should know is 1 to any power is just 1. So we got 2 minus 1/2 times 1. Okay. So that's 2 minus half. Once again, when you subtract 2.5, we need to rewrite 2 as 4/2. Okay, so you need to use the same denominator when you do addition or subtraction of fractions. So that will give us 4/2 minus 1/2. Then you can just subtract 4 and 1, we get 3 on the top, and we keep the denominator as it is. So that's the slope. So that's the slope of the graph at 1, 3. And then the next thing we need to do is to find the equation of the tangent line. So of the graph at this point. Okay, so the tangent line is so we have the slope of the line, and we know the tangent line passing through this point. So we can use the point slope formula to write down the equation of the line. So the point slope form of the line is y minus y1 equals m times x minus x1, where m is 3/2 the slope, and x1 is 1, y1 is 3. So we can just write down the equation of tangent line as y minus y1, which is 3, equals m, which is 3/2 times x minus x1, which is 1. Okay. So now we can simplify the whole thing as if we multiply 3/2 on the right side and combine like terms, so then we can we simplify the whole thing. So we get y minus 3 on the left hand. We get that 3/2 x minus 3/2 on the right. If you distribute it and 3/2 on the right. Okay. And then we can do one more step to simplify the final answer. So we can add 3 on both sides. So that becomes y equals 3/2 x plus minus 3/2 plus 3. Okay. So again, we need to, combine -3 and -3/2 and 3. So again, we're going to rewrite 3 as 6/2. We need to use denominator 2. All right. Use the same denominator. So, all right. So now we are almost done. Okay. So just combine -3/2 and 6/2. So we got -3 plus 6 on the top. So that's +3 and 2 in the denominator. So it becomes y equals 3/2 plus 3/2. So that's the final answer.